Now that the subcooling at the outlet of the condenser and the superheating at the compressor's inlets are taken into account, and now that we can also consider the irreversibilities across the compressor using the isentropic efficiency, then we can plot again the vapor compression cycle, but this time something that is close to what is really taking place into the machine, and not the ideal vapor compression cycle than before, like before. So now we will plot this one in a TS diagram, temperature, specific entropy. So maybe first thing to plot is the two isobaric lines corresponding respectively to the low pressure and to the high pressure. And if we want to start by plotting the compressor inlet, so what's called point A, we can start here. This temperature corresponds to the evaporation temperature, and if we know the value of the superheating, for example 5 Kelvin of superheating at compressor inlet, so that would correspond to this difference of temperature for the superheating. So we know exactly the temperature of point A and also the pressure, and we can write directly point A somewhere there. Then for the compressor's outlet, we'll start with the point B is, so that corresponds to the outlet we would have with the non-adiabatic reversible compression from point A to the high pressure. So in that case, because specific entropy is the x-axis, we can go directly vertically up, and when the high pressure isobaric line is crossed, it corresponds to point B is. Then once we are there, we can calculate the specific enthalpy of point B real using the isentropic efficiency. So it was written before that specific enthalpy of point B is equal to specific enthalpy of point A plus the difference of specific enthalpy between A and B is divided by the isentropic efficiency of the compressor. So in order to calculate this, you need to read on the diagram the specific enthalpy of point A and B is. So the shape of the iso enthalpy line is like this. So that would be the specific enthalpy of point A, specific enthalpy of point B is, and then once the specific enthalpy of point B is calculated, then we can look for this iso line HB, and the crossing with the high pressure isobaric line corresponds to point B. Then the working fluid at point B state will enter the condenser. So by exchanging heat with the hot source, this working fluid will be cooled down to saturation, then completely condensed, and then we will take into account a subcooling at the end of the condenser. So the subcooling is defined from the condensation temperature, so that's T count, and if we know the value of subcooling, for example 3 Kelvin, we can look here for the real value, so that's the delta T of subcooling. cooling, and that will correspond to the temperature of point C, and then at the crossing with the high pressure isobaric line we have point C. And next step between point C and point D, through the expansion valve, the specific enthalpy remains constant, so you can just look for the iso enthalpy line corresponding to the specific enthalpy of point C, and the crossing with the low pressure isobaric line here corresponds to point D. And all the different characteristic points of the cycle are plotted. The fourth step is the fluids entering the evaporator at point D, and then the fluid is completely evaporated and a little bit superheated until point A. So that's the real vapor compression cycle in a TS diagram.